Chapter 5, Functions and Graph. Continue on 5.1, Functions. These are the learning outcome for these subtopics. Sketch a constant function. Constant function is a straight line. So examples, fx equal -3. Fx also considered as y equal -3. Y -3 is here, and then draw a straight line at y equal -3, and then label the graph. Fx equal -3. Next example, x equal to 2. A constant function where x equal to 2 is here. So draw a straight line where x equal 2 and label the graph. X equal to 2. So for every value of y, x equal to 2. And then linear function. To sketch a linear function, we need 2 points. Normally, we put x equal to 0, or also known as y-intercepts, and y equal to 0. This is x-intercepts. Okay, for x equal to 0, substitute x into the function. Y equal to 4, x is 0 plus 1. So y equal to 1. And for y equal to 0, x equal to -1/4. And then sketch the point. When x equal to 0, y equal to 1 here. When x equal -1/4, y equal to 0 here. Draw a line connecting these 2 points and then label the graph. So this is a graph for fx equal to 4x plus 1. Next example, 4x plus 1. For x less than 5. For these examples, we have domain x less than 5. We still need x equal to 0 and y equal to 0, which is 1 and -1/4. And we must include the domain x less than 5, so the last endpoint is 5. When x equal to 5, y equal 21. X equal to 0, y equal to 1, here 1. X equal -1/4 and x equal to 0. Starting point or the end point is x equal to 5 and y equal 21. Since x is less than 5, so 5 is not included, means 5 here is a circle. And then connect these 2 points. With starting point x equal to 5. So linear graph is a straight line. This must be a straight line, so please use a ruler. Line must exceed the point -1/4. Stop at 5. Stop exactly at 5. Okay. Then label the graph fx. So this is a linear graph for x plus 1 with domain x less than 5. Means for x greater than 5, there are no graph or no lines. For x plus 1, for x between 1 to 5. For this graph, x equal to 0 is not in the domain because x start from 1 to 5. So no need for x equal to 0. And for y equal to 0, also x equal -1/5. And since it has a domain from 1 to 5, the domain must include in calculation. X equal to 1 and x equal to 5. When x equal to 1, y equal to 5, and when x equal to 5, y equal 21. Then sketch graph here. X equal to 1, y equal to 5 included, and when x equal to 5, y equal 21 not included. Connect these 2 points. X equal to 1 up to x equal to 5 not included. Then label the graph. Fx equal to 4x plus 1. Extra example, fx equal to 2x. Normally for linear graph we need x equal to 0 and y equal to 0. But for this case, when x equal to 0, y equal to 0, And when y equal to 0, x equal to 0. So you'll have a dot, x 0, y 0. And for linear graph, we need 2 points. So cannot use x equal to 0 and y equal to 0. In this case, we need 2 points, x equal to 0 and let's say x equal to 1. When x equal to 0, y equal to 0. And when x equal to 1, y equal to 2. We'll have 2 points, x equal to 0, y equal to 0. And when x equal to 1, y equal to 2. Connect these two lines with a straight line. Then label the graph. Fx equal to 2x. For quadratic function, we have 4 steps. First, shape. Okay, shape for quadratic function, we have smile graph and set graph. Smile for a greater than 0, set graph for a less than 0. This is a set graph, this is a smile graph. Second, maximum or minimum point. Calculate x equal to negative b over 2a. Substitute x into y to get maximum or minimum point. Then sketch graph. The last one, find the xy intercept. X equal to 0 and y equal to 0. Both fx equal to negative x plus 4 squared. So this is a quadratic graph since it has x squared. First, shape. Notice that negative here, so this is a set graph. Okay, maximum or minimum point, since this is in the form of completing the square, so x is inside the bracket. X plus 4 equal to 0, so x equal negative 4. And y is plus constant. Outside the bracket, plus 0. So maximum or minimum point is negative 4, 0. Third one, sketch graph, and then find intercept or domain if any. This set graph, maximum minimum point negative 4, 0. So negative 4 is here and 0. So this is a minimum. Going up and then down again. Make sure your graph is a smooth line. If there are any intersection, calculate the value for x or y intersects. So this one here cross at negative 4, and then we have y intersection. Y intersection is when x equal to 0. When x equal to 0, y equal negative 16. When y equal to 0, x equal negative 4. And don't forget to label your graph fx. Example, fx equal to negative x squared plus 2x. Again, the same step, shape. Look at the x square function here. Since x squared is negative, so shape is set graph. Maximum or minimum point, x equal to negative b over 2a equal to b is 2, 2a is negative 1, and then x equal to 1. When x equal to 1, y equal to negative 1 square plus 2 times 1. So y equal to 1. Therefore, maximum or minimum point is 1, 1. And then sketch graph, then intercept or domain, if any. Maximum or minimum point is when x equal to 1, y equal to 1 here. Set graph, so start from below going up. So this graph will cross at axis, either at x equal negative or positive values. So since we already know it will have x intercept, calculate the point. 0, y equal to negative 0 square plus 2 times 0 equal to 0. And then when y equal to 0, negative x square plus 2x equal to 0. So negative x x minus 2 equal to 0, x equal to 0, and x equal to 2. Okay? So when y equal to 0, x equal 0 and 2. When x equal to 0, y equal to 0 means the graph will cross x0, y0, and when x equal to 2, y equal to 0 also will cross here. And then connect the points with linear graphs, start from below and then going downwards. Then lastly, label the graph. Next example, fx equal to 3x squared minus x plus 2. Shape, look at the x square is positive, so smile graph. Maximum or minimum point, x equal to negative b over 2a, negative 1 over 2 times 3, 1 over 6. When x equal 1 over 6, y equal to 3 times 1 over 6 square minus 1 over 6 plus 2 equal to 23 over 12. Therefore, the maximum point is 1 over 6, 23 over 12. Sketch graph, then find the intercept. The shape of graph is smile. Maximum minimum point 1 over 6 and 23 over 12. This graph is a smile graph, so it's going up, and then this is the minimum point. So the graph won't cross as this, as it will be up here. And sketch the quadratic smile graph. Then we know it has a y-intercept when x equal to 0, y equal to 2. And last, label the graph fx. Last example for quadratic graph, fx equal to x minus 2 times x plus 1 for x between negative 2 and 3. For this function, shape is x times x, positive, so smile graph. Maximum or minimum point, we need negative b over 2a, so expand x squared minus x minus 2. So maximum point, x negative b over 2a, negative 1 over 2 times 1, x equal 1 over 2. When x equal 1 over 2, y equal to 1 over 2 square minus 1 over 2 minus 2. Y equal negative 9 over 4. Therefore, maximum point is 1 over 2 and negative 9 over 4. Sketch graph, intercepts. For intersection, x equal to 0, y equal to 0. When x equal to 0, y equal negative 2. When y equal to 0, x equal negative 1 and 2. And then since this graph has domain from negative 2 to 3, include the domain in calculation. When x equal negative 2, y equal to 4, and when x equal to 3, y also equal to 4. Maximum minimum point 1 over 2, negative 9 over 4, x equal to and negative 2. When x equal negative 2, y equal to 4, and when x equal to 3, y also negative 4. Sketch the graph, quadratic graph. Label the graph. X equal to x minus 2 and x plus 1. These are your exercise. Please submit the exercises at the end of this lecture.